All right, let's dive into a cosmic mystery. We're going to take a look at a galaxy that, for the longest time, everyone thought was, well, kind of boring. It's called Messier 105. Astronomers looked at it as the perfect textbook example of a galaxy. But it turns out its quiet exterior is hiding a seriously turbulent past.
So here it is. It's about 35 million light-years away from us, hanging out in the M96 group in the constellation Leo. M105 is what's known as an elliptical galaxy, which is basically just a giant, smooth ball of old stars. And for years, astronomers loved it because it was so simple, so predictable. It played by all the rules. But as we're about to see, that was all just a very, very convincing act.
And that's really the big question we're going to tackle. What if this picture of calm is totally wrong? We're going to treat this like a cosmic crime scene, following a trail of clues left behind over billions of years to uncover the secret history of Messier 105.
Okay, so clue number 1. Where do you even start looking? Well, you go to the most fundamental thing a galaxy is made of, its stars. And when astronomers looked really closely at the individual stars inside M105, they found something that just didn't make sense.
So to get this first clue, we need to talk about something called metallicity. Now, it sounds complicated, but it's not. In astronomy, metals are pretty much any element that isn't hydrogen or helium. A star's metallicity is like its chemical DNA. It's a fingerprint that tells you where it came from, what ancient gas cloud it was born in. It's basically a star's birth certificate.
So back in 2016, a team of astronomers pointed the incredible Hubble Space Telescope right at M105 to do exactly that, to read the chemical DNA of its stars. And they looked at 2 different spots, one area near the galaxy center and another way out in its remote suburbs.
And this is what they found. Whoa. Each of these graphs is like a population census, but for star DNA. The graph on the left, that's from the galaxy's core. See that one big sharp peak? That tells you there's one dominant family of stars there, all with similar metal-rich DNA. But now, look at the graph on the right, from the outer galaxy. Suddenly, a second, totally distinct peak pops up. A completely different, metal-poor family of stars is living out there. It's like finding a lost tribe living just outside the city.
So the takeaway was huge. M105 isn't one big uniform family of stars at all. It's 2. You've got this metal-rich family that runs the inner city, and then this other, metal-poor family living on the outskirts. This was a massive clue, but the mystery was just getting good. For the next piece of this puzzle, we have to go looking for ghosts.
All right, let's move on to our second clue, which is where things get even weirder. This one doesn't come from living stars, but from the faint glowing ghosts they leave behind when they die.
These ghosts are actually called planetary nebulae. When a star, like our sun, gets really old and starts to run out of fuel, it sort of puffs its outer layers of gas out into space. For a little while, that glowing shell of gas is lit up by the dying star in the middle, and it creates this absolutely beautiful but very temporary object. So, if you can count these stellar ghosts, you can basically figure out where stars have lived and died.
So in 2020, another group of astronomers decided to use these ghosts to map the really distant edges of M105. They expected a pretty simple result. As the galaxy's light fades out, the number of ghosts should fade out with it. Simple, right? Yeah, well, that is not what they found. Not even close. Check out this graph. This is the smoking gun. That solid line shows the galaxy starlight, and you can see it fades away smoothly into darkness, exactly like you'd expect. But look at the black diamonds. Those are the stellar ghosts. At first, they track along with the light, but then they just don't. Out in the suburbs, their numbers stay stubbornly high. There were way too many ghosts haunting the edges of this galaxy. This was the second huge mystery. I mean, where were all these extra ghosts coming from? They had to belong to a group of stars that wasn't very bright, something faint and spread out that was essentially hiding in the darkness. And this is the moment. This is where our 2 separate clues just snap together perfectly. You've got a mysterious population of stars with different DNA, and a mysterious population of stellar ghosts. Could they be the same thing? And the connection was flawless. The exact region of the galaxy where that metal-poor family of stars started showing up was the exact same region where astronomers found this huge surplus of stellar ghosts. The 2 mysteries had the same address. It was not a coincidence. As the researchers put it in their paper, this establishes the missing link. The conclusion was suddenly simple: the extra ghosts belong to the immigrant stars. It turns out, for reasons tied to their specific chemistry, this metal-poor star family produces way more of these bright stellar ghosts than the native metal-rich stars do. The two clues weren't two different mysteries at all. They were just two sides of the same incredible cosmic coin.
This means M105 isn't one single thing. It's two galaxies, nested inside each other like a Russian doll. It has a dual halo. You have the main, bright, metal-rich galaxy we've always seen, but surrounding it is a second, huge, faint, metal-poor halo that was built from something else entirely. So the final question is, how on earth did it get there?
And this is where solving the mystery of one boring galaxy pulls back the curtain on how all massive galaxies like M105 are actually put together.
All this evidence points to a theory called the dual halo formation model, and M105 is now the poster child for it. This diagram here lays it all out. Building a giant galaxy isn't something that happens all at once. It's a two-phase construction project that takes billions of years.
So first you get what's called in situ formation. This happens early in the universe. A gigantic cloud of gas collapses in on itself and starts furiously making stars. This creates the dense, metal-rich core of the galaxy. Think of it as the downtown core. Then comes phase 2, accretion. For the next few billion years, that big galaxy's gravity acts like a giant vacuum cleaner, pulling in and just devouring countless smaller, metal-poor galaxies that get too close. And those shredded galaxies don't just vanish. Their stars get added to the bigger galaxy, building up this enormous, faint, metal-poor outer halo. These are the cosmic suburbs, built from the remains of other towns. So when we look at M105 today, we're not just seeing a galaxy. We're actually looking at a cosmic archaeological site. Its dual halo is a fossil record of its own violent, cannibalistic past. It's telling a story of construction through destruction. And this leaves us with just a really fascinating thought. Remember, M105 was supposed to be the simple, boring one. So if a so-called standard galaxy is hiding a history this complex and this violent, just imagine what other incredible secrets are still out there, waiting for us to find them in all the other galaxies across our universe.